Welcome to Spring LIB.
Okay, we are shown acetic acid and trimethyl ammonia rather. And we need to draw the product of the acid-base reaction that takes place between these two reactants. And for instructive purposes, I will just show the mechanism rather than jumping straight to the solution so we can at least glean a little bit of knowledge as to why this happens. Recall that the lone pair on nitrogens is fairly basic, right? And so that is what will behave as the base to deprotonate the fairly acidic acetic acid. The electrons that form the oxygen-hydrogen bond will remain behind on oxygen, giving us what's known as an alkoxide, like so. And since this is a Bronsted acid-base reaction, you're instructed to draw both reactants in separate sketchers and to include all non-zero formal charges. Additionally, you are to include all valence lone pairs in your answer. So if we look back at the original product, recall, or substrate, remember there were two lone pairs on this oxygen, and although I did not draw them in, there are two lone pairs on this oxygen. Okay, so in the final product, nothing would have changed about these lone pairs, but we would have gone from having three lone pairs on oxygen to an additional lone pair generated from the movement of the oxygen-hydrogen bond onto oxygen. I will draw this lone pair in red to indicate where it came from. Likewise, we need to draw the base pair or the conjugate base of our trimethyl ammonium, which would be a nitrogen with still 3 bonds to methyl, as well as now a bond to hydrogen, and it would no longer have a lone pair. However, it would have a positive charge.